Good morning, students.
Good
Morning,
morning, sir.
students. Hope I am audible.
Yes, sir.
Yeah, we'll start on time or class. Class. Today's class is on Ethernet protocol, and in Ethernet protocol, we'll discuss about the physical properties of Ethernet, the accessing protocol, the frame format, the addressing type, and the transmitter algorithm considering Kiriarson's multi-access. So we discuss about one persistent, p persistent, and we discuss. And even though other networking components are there, connectivity components are there, why still Ethernet is popular? That's what is the topic that we are going to conclude at the end. Coming on to Ethernet. Ethernet, what is exactly Ethernet? Ethernet is your interconnection of two computers using LAN cable. So that cable. So it may be a point-to-point network, or it may be local area network. So Ethernet eventually became the dominant local area network technology, emerging from a pack of competing technology. And uh, today it competes initially with 802.11. 802.11 is your wireless. So if you look at personal network, personal computer network, there are two components. One is using LAN with Ethernet. It is connectivity, physical connectivity. Second one is your wireless network, but remains extremely popular in the campus networks and the data centers. So even today, people use Ethernet because of its simplicity, low maintenance cost, and also high reliability. That is a main reason for it. And more general name for the technology behind Ethernet is CSMA, CD, Carrier Sense Multi-Access. So this is one of the very important technology where multiple people are accessing the same link. How exactly it works with carrier sense multi-access with collision detection. So that is what we discussed. CSMA, carrier sense multi-access. What is exactly? Ethernet is a multi-access network. So that means multiple people are accessing. So meaning that set of nodes sends receive the frame over the same shared link. And of course carrier sense, before you transmit the data, you read, you sense the carrier, that is a communication medium, you sense it. And based on this sensation, what happens, so you will detect somebody is sending or not. If it is idle, you will send. If it is busy, you wait. Or else if you send, both of them send, so what happens, there is a collision. So collision also happens between packets when you transmit in the both directions. Of course, you can see the collision detection means that a node listens as it transmits, and can therefore detect when frame is it is transmitting has inferred, that is collision. So with the other transmitting frame with another node. So if two nodes transmit the data simultaneously, so what happens, there is a collision, happening. So this collision is nothing but it is a loss of data. So two packets will collide, coming in the opposite direction. They collide at some point, and they lose some data. So the modern Ethernet links are now largely point to point. So point to point means there is only one node to node. So there is only one connection between one node to another node. So there is modern networks. Certainly, they have this kind of thing. And further, uh, further, if I take, that is, they connect one host to the Ethernet switch, or they interconnect the switches. So they interconnect the switches, or through switch they will connect. So that is what we call it as point-to-point network. Hence, multi-access techniques are not used much in today's Ethernet. So today we don't have this problem of collision, because we'll make use of switch. That means switch is one node. So from switch to another node. One second, I just disable my, yeah, I just disable, one second. Yeah, I just disable, yeah, so that I don't get, yeah. So normally we will have you know in a LAN we have a switch. So this is a switch, and from one switch we'll connect to one computer, and this is again a point-to-point network. So this is one computer, one point, this is another point. So this is a switch, I can say it's a switch. So switch, you know, switch to one computer, another switch to another computer. So certainly you can have. So there are point-to-point networks. So since you have point-to-point network, so what happens? There will not be any problem. So whatever the data you send it to a switch, and switch will forward it further. So there will be less collision. That's what we see. Hence, multi-access techniques are not used much. So multi-access means you have a common line, and in the common line you have the computers connected like this. So there is one computer, there is another computer connected. So there is a common line between them. So you can see there is a common line. So you can have a line like this, common line. So there is one more line. So like this. So this line is very common. And when you have common line like this, and if both the computers are transmitting, so definitely there will be a problem. So if the transmission happens in this way, there is no way. In this way, this computer this way, there is no collision. In case if this computer wants to transmit to this and this computer wants to transmit this, so definitely there will be a collision. So collision is most common in multi-access networks. Since we are using point-to-point networks with respect to switch, so today, most of the collisions are being, removed. So that is what we have to understand. And the physical properties, when you are, whenever in an examination, if a question is asked, explain the, explain about Ethernet. So you are supposed to write, okay, Ethernet, physical properties, that, what is this Ethernet, what are the physical properties, what are the other accessing algorithms, accessing protocols, what is the frame size, etc. You have to write. So Ethernet segments are originally implemented using coaxial cable that we have already seen, the coaxial cable, maximum range of 50 meters, sorry, 500 meters, almost half kilometer. So half kilometer range it will run. And modern Ethernet uses twisted copper pairs, usually particular type known as category 5 or optical fibers. In some cases can quite a lot longer than 500 meters. So when you use category 5 or optical fibers, it can be much distant also. So you can expect some distance with respect to communication. Yes, and this cable was similar to the type of cable TV. The host connected to Ethernet segments by tapping on it. Of course, it is there. It has a trans receiver. Normally, this physical connection has a trans receiver. What is the meaning of trans? It is a transmitter as well as receiver. So a small device directly attached to the tap detected when the line was idle and dropped the signal when the host was transmitting. And of course, it is also receiving the incoming signals, and of course, transceiver in turn is connected to Ethernet adapter, which is plugged into your host. So it is just like this. You can see a transceiver. So transceiver is connected like this, and which is connected to your adapter. Adapter is connected to your computer. There's actually a transmitter as well as receiver. This is the one. If it is transmitting, it will make the data incoming to wait, and once you receive the data, then it will be passed on to the adapter. So that is the thing. Next is uh, multiple Ethernet segments can be joined by a repeater. There is a device called a repeater. So you have to understand there is a device called repeater. Repeater is just like your amplifier. So what happens as soon as the signals transmit over a link, so as the distance goes, the signal becomes weak. So what do? You put an amplifier. So amplifier will bring the low range signal, weak signal into strong signal or normal signal. Repeater also does the same thing. What it will do, it will take the signal from the one end, repeats it in the other end. So with the proper signal. Okay. Repeater is a device that forwards the digital signal much like an amplifier. I just told the same thing, amplifies and forwards the signal in the other line. And of course, you can see repeater understand only bits and not frames. However, no more than four repeaters could be positions between any pair of hosts. So in maximum, you can certainly have. So in this diagram itself, you can see there are four repeaters which are connected to multiple hosts. And of course, it is also possible to create a multi-way repeater, so called hub. So hub is one wherein you can connect multiple connections to a repeater. And of course, a signal placed on the Ethernet by host is broadcasted over the entire network. That is, the signal is propagated in both the directions, and repeaters and hubs forwards the signal in all outgoing lines. So if you have some data to be transmitted, so to all the computers that is broadcasting, so what they'll do, they'll put the signal to this line, to this line, this line, this line. This repeaters will repeat it. Okay, it will be transmitting. Next, we have is what we call it as, I'll just clear, yeah, terminators. Terminators attached at the each end of the segment absorb the signal and keeps it from bouncing back and interfering with the trailing signals. So normally what happens, if you look at the previous diagram, so in the previous diagram, the terminals, the last ending computers, so will absorb the signal. It will not send the signal further. What it will do, it will absorb the signal. If it doesn't absorb the signal, what happens? The signal moves in the other direction, reverse direction also. So if it moves in the reverse direction, what happens? There are chances that it may collide with other signals. So that is the reason terminals will absorb the signals, keep it from bouncing back and interfering with the trailing signals. The original Ethernet specification is used Manchester encoding. So Ethernet uses Manchester encoding. We have already seen what is Manchester encoding, and it is important to understand that whether given Ethernet spans in a single segment, a linear sequence of segment connected by repeaters, or multiple segments connected in a star configuration by hub, and of course data transmitted by any one host on the Ethernet reaches all the other nodes. So it can be a broadcast, it can be unicast, it can be multicast, and of course, meanwhile, either you can use a repeater or you can use a hub. So hub and repeaters performs the same thing. Multi-access part of the Ethernet is still all about dealing with computation for link that arise in the in a collision domain. So if there is only one link between two computers and whom you are going to allocate, that is the biggest challenge, and where you have a competition among the computers for acquiring that particular link. So you can see, yeah, there is a common link. You can see hub. So hub generally connects like this, and this link is a common link. For acquiring this link, there will be a competition among computers. So that is the thing. And this is actually the protocol that we use for Ethernet. So whenever you send data to it, so what you'll do, you send first a preamble. Preamble are synchronous bits. You have a destination address, you have the source address. So destination address and source address, this level, actually it doesn't mean that they are, you know, uh, IP address. They are MAC address, physical address. MAC addresses are, we call it as physical address. Physical addresses are available or imprinted by the manufacturer on the network card, NIC card, network interface card. On the card itself, it is there. So every computer, every mobile phone, every device on the network will have this, MAC address. MAC address is nothing but physical address, the address which is being embossed on the motherboard of your network, card, network card. So network interface. So it will be available. So based on this, that's why the address is, you can see, 48 bits. So somebody can ask in the exam or interest. So what is the size of MAC address? MAC address, the physical address is 48 bits. And of course, the type of addressing, whether you are doing unicasting or multicasting or broadcasting, and body, where you send the message, and CRC to check the errors. So our algorithm to access the internet shared link, and of course, so this is called the media access control, and it is typically important hardware in the network adapter. So we call it as MAC, and it uses 64-bit preamble for synchronization. So just to get synced. So some device sender and receiver are in a different speeds. So just to bring them to a common speed for transmission and reception. So we certainly use this preamble. Once preamble is done, both source and destination hosts are identified by 48-bit address. This is physical address, and that packet field serves the demultiplexing key, and that is identified by possibly many higher level protocols. Uh, this frame should be delivered, and of course, the frame can contain up to 1500 bytes of data. Minimally, frame can send only 46 bytes of data, so it is very minimum. Even if this means that host had to pad some frame before transmitting. So the reason for this is minimum size frame sizes 46, maximum is 1500 bytes, and of course finally it is ended with 32-bit CRC for checking the error bits. Now addressing, there are addressing issues. So Ethernet in the world has unique Ethernet address. Ethernet address are nothing but physical address. So physical address that are available on the adapter. Okay. So technically the address belongs to adapter, not on the host. So host address, if you take it, is an IP address. IP address you can change. And it is dynamic. But the physical address is fixed, and it is usually burnt on the chip of ROM, and it is placed on network adapter. So its physical address is kept. And Ethernet host in the world has a unique Ethernet address. So every computer, every laptop, every networking device has unique Ethernet address. And technically, the address belongs to the adapter, not the host, and it is usually burnt on raw, and specific address you call it as a unicast. So using this address only, if you specify, if you transmit the data to only a one particular address, specific address, then it is called unicasting. Ethernet address consisting of all ones treated as broadcast. So in the type address type, if one is there, that means it has to send it to all the nodes that all the nodes in the network. So we call it as broadcast. If the first bit is set to 1 but not the broadcast address, it is also called multicast addressing. So what happens, 1 you can set, and further you can set the the screening bits, the screening, using screening bits. What happens, the multicast routing happens. So multicast routing, only selected nodes will get the data. So that is what we call it as multicast routing. And when we look into the transmitter algorithm, so in order to transmit the data, what algorithm your Ethernet follows? When an adapter has a frame to send and the line is idle, it transmits the frame immediately. There is no negotiation with the other adapters. And upper bound is 1500 bytes in the message, means that the adapter can occupy the line only for fixed length of time. So 1500 bytes, in the sense it can transmit for only 2 seconds. So 2 seconds, within 2 seconds normally 1500 bytes are transmitted. And when the adapter has a frame to send and the line is busy, it waits for the line to become idle, and once the line becomes idle, it transmits immediately. And the Ethernet, this type of Ethernet, we call it as one persistent. One persistent because it will wait uh, for one probability of 1. So it will wait for one probability time and before it transmits. So because an adapter with the frame to transmit with have a probability of 1 whenever the busy line goes idle. And this is what we call it as persistent, one persistent CSMA. Carrier sends multi-access. Before transmitting, it will wait so for some time, and it will transmit. So that is what we call it as one persistent. Next, whenever the sender, the station is ready to transmit, it checks if the physical medium is busy. It sends the medium continuously until it becomes idle, and then it transmits a piece of data. Yes. So when it is idle, it will transmit. In case of collision, suppose both the stations senses there is a line which is idle, they simultaneously transmit by mistake. Okay, simultaneously they sense that both the stations sense that line is idle, and simultaneously they'll transmit the data. In such cases, what happens, the collision happens. The sender waits for a random period of time and attempts to transmit again. So when the collision happens, it waits for some random amount of time and transmit again. So that is what you see, one persistent. In P persistent, P is nothing but probability of persistent, probability of waiting time. So in general, P persistent algorithm is a probability between 0 to 1. So there is a probability. So whenever you look into the probability calculations, so probability varies between 0 and 1. So after the line becomes idle and differs with the probability, Q is equal to 1 minus P. So with the probability, it will send. The reason behind choosing P is less than 1 is that there might be multiple adapters waiting for the busy line to become idle, and we don't want all of them to begin transmitting at the same time. So that's why they have to wait. Each adapter transmits immediately with the probability of say 33%, then up to 3 adapters can be avoided to transmit, and the odds are that totally one will begin transmitting when the line becomes idle. And of course, despite this reason, Ethernet adapters always transmit immediately after noticing that the network has become idle and has been very effectively doing so. And normally collision, where whenever you have an Ethernet so, because there is no centralized control, it is possible for two or more adapters to begin transmitting at the same time, either because of both directions found in the line, or because both had been waiting for a busy line and becomes idle. Suddenly they transmit. So when this happens, two or more frames are said to be colliding in the network. So both the frames get disturbed. So each sender, because the network support collision detection, so what happens? So both frames are discarded, able to determine the collision in process, and of course, at that moment, the adapter detects that the frame is colliding with another frame and make sure that it transmits a 32-bit jam sequence. So it will send a jam sequence back to the other nodes, telling that there is a collision. So the transmitter, minimally sends 96 bytes. We call it as a runt frame, which will tell the all other computers that there is a transmissional, collision happened. So all the systems have to wait for the collision to get cleared. So cleared in the sense all that colliding, bits are becoming neutral, normal, zero. So look at here. So we have slots in the first slot. First frame is station one is transmitting. When as soon as the time finishes, both the stations 2 and 3 they start transmitting simultaneously. So what happens? There is a collision happens. So and again wait for next slot of time. The next slot of time, if frame 1 and frame 4 transmits together, so there will be a transmissional error. And in the fourth slot, if only 2 is transmitting, there is no. If fifth slot only 4, there is no. In third slot, there is no. In sixth slot, third station is transmitting, so there is no collision. So in the same slot, if two systems transmit the data, definitely there is a collision. So this is how the collision will happen. These are the reason. But how to avoid this collision detection? It's very simple. Make all the network connections in the LAN as P2P, point to point connection with respect to the switch. So what happens? There will not be any common line. So switch will take care of forwarding the signal in sequence. So there will not be any error. So there will not be any collision. So everything goes well with respect to point-to-point switched network. So in the LAN. So there are some, even though you have problems with you know, collision, problem with the Ethernet, collision and other error, prone, situations. So there are still Ethernet is very popular, and of course, even today we are transmitting the data via air, so wireless transmission. Still, people are using Ethernet. So, in spite of wireless transmission, people are using. The reasons are: first reason is the Ethernet is extremely easy to administer and maintain. There are no switches in the original Ethernet, no routing, no confusion table, no configuration table to be kept and updated. It is easy to add a new host to the network. It is very easy to maintain, manage. Second is it is inexpensive. Inexpensive means there is no much cost is required compared to other type of networks. Communication becomes very costly. So here, cable is very cheap, and The only other cost is network adapter. Adapter you have to buy and connect it. So that is the only cost that you are incurring. Ethernet become deeply entrenched for these reasons, and any switch-based approach that is aspired to displace it requires additional investment and infrastructure on switches on top of cost of adapter. So maybe that is the reason Ethernets are still popular. Okay, and as we'll see in the next chapter, switch based networking technology did eventually succeed in replacing multi-access ethernets switched networks. Okay, so in the next class probably we'll discuss about wireless network. So sorry, token ring, we'll discuss about token ring, and later we'll discuss about wireless network. So finally we'll discuss how these switch based ethernets are formed. And today we are all enjoying the switch based LANs. So switch based LANs are most popular, most commonly used, and less prone to difficulties, or I can say less prone to errors. So that's all for today's class. In the next class, we'll discuss about token ring network, wireless networks, and also we'll discuss Bluetooth communication. Thank you for attending my class. All your class recordings will be available in this particular website, and the class material, study material, is also available in this website. Meanwhile, listen carefully. I'll be giving assignment questions. You have to write these assignment questions and prepare a PDF file using Cam Scanner and upload it in the uh, network. Upload it in the the link which I have given it. So that's your concept. That's all for the day. Thank you. Have a wonderful day.